So if it's a square root, it cannot have any perfect square factors. If it's a cubed root, it can't have any perfect cube factors. So whatever your index is, it can't have those perfect root factors. For the most part, we are going to see squares. So we're looking for perfect square factors. Some other rules that are helpful and are necessary are that we can split up roots and go back and forth based on the operation that we're doing. So if we have the square root of m times n, we can split this to be the square root of m times the square root of n. And that's how we're going to be able to simplify when we have perfect square factors. This also works vice versa. So if you have the square root of m times the square root of n, you could multiply those together. So if I had something like this, square root of 3 times the square root of 2, I could also write that how? 6. Multiply them, right? mn. So we could multiply them together and keep them under, or we can separate them into factors. Square root of 3 times the square root of 2. Same thing works with division. So we can do the square root of m over n. What does a fraction bar mean? Divide. We could also write this like this. The square root of m divided by the square root of n. And sometimes that helps us simplify. For example, if we have something like the square root of 100 over square root of 36, that is not something that we could easily simplify. However, if we split them and say the square root of 100 divided by the square root of 36, these are both perfect squares. Square root of 100 is 10, square root of 36 is 6, and then we can just divide by 2. So it kind of helps you to know that you can go back and forth to figure out which way is going to be easiest to solve whatever problem you have. So know that you can split them up or put them back together. Same thing with multiple factors. So if you have a big number and you can divide it into 4 different factors, this could be written as square root of m times the square root of n times the square root of o times the square root of p. And then we can simplify. So we're always looking to simplify. Okay, you should, and I haven't decided yet if I'm going to give you a quiz on it, memorize these perfect squares and perfect cubes. Because if you can recognize these, it's going to be easier for you to simplify your square roots. Your calculator won't help you if you don't know what the perfect squares and perfect cubes are. It can help you do the division, but you have to know what to divide by. So, but that's what I'm saying. I'll show you. If you can't recognize a perfect square, you're not going to be able to simplify your roots. You have to just be able to recognize it. Okay, 1 squared is 1. 2 squared is 4. 3 squared is 9. 3 times 3, right? When we square something, we multiply it by itself. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. This is when they get a little bit more difficult because we don't see them a lot. 11 squared is 121. 12 squared, 144. 13 squared, 169. 14 squared is 196. And 15 squared is 225. You should be able to recognize those. Okay, I made a Quizlet for you. I posted it on Canvas. So I'll have you do that when we start our homework. Okay? Because I may give you a quiz. I haven't decided if I'm going to do that yet, just to make you memorize these. All right, perfect cubes. 1 cubed is 1. 1 times 1 times 1 is 1. 2 cubed is 8. 3 cubed, 3 times 3 is 9, times 3 is 27. 4 cubed is 64. 4 times 4 is 16, times 4 is 64. 5 cubed is 125. And 6 squared is 216. You aren't going to see too much higher than 6 cubed. I think I said squared, but cubed. Okay, there are 2 ways to simplify roots. I prefer this way, and this is the way that I'll do it, is to split it into perfect square factors. But you will see it done in different ways, but we're going to mostly do this way in here. I'll show you both in case you use the other one. But my experience generally has been when people do the second method with the factor tree, they mess it up and they don't understand why they're doing it. So, first one, to split it into perfect square factors or perfect cubes or whatever, you need to know your perfect squares. Oops, perfect squares. So you have to be able to recognize those and see what goes into your radicand. Then you separate that square root, like we talked about on the first page, into factors. So if it's like the square root of 40, we could separate that in the square root of 4 times the square root of 10. So separate the square root into, actually, let's say separate the radicand. That would, I know, I want to be more clear. Separate the radicand into factors. And then simplify the perfect squares. So like I said, this is my favorite way to do it, and this is how I'm going to show you how to do it, because I think generally it's makes more sense. But there is another method, which is you make a factor tree. Of the radicand, which is the number under the root. So you find all of its prime factors. And then you set any pairs of factors outside the radicand. So I'll show you both ways. Okay, any factors without a pair, stay under. So I'm going to do this up in the margin, and we'll just look at both ways. If I have this, the square root of 250, and you have to simplify that. That is not simplest form. If we use way 1, I'm going to separate the square root of 250, and I'm going to try to figure out what perfect square factors go into it. If you need to flip back on your front page, maybe you know what goes into 250 that would be perfect square. 25. So we're going to rewrite this as square root of 25 times the square root of 10, right? One of these simplifies because it is a perfect square. What is the square root of 25? 5. Remember, this is multiplication. So we're going to simplify this as 5 times the square root of 10.
We already did this.
Yes, you should know how to do this. We have done this before. Okay, so that's it. I can't simplify 10 because it doesn't have any perfect square factors. Okay, the other way we could do this is with a factor tree. And the way that this looks is you do that prime factorization, and so you write prime numbers. 250 is 2 times 125. 125 is 5 times 25. And then 25 is 5 times 5. So for this method, we have a pair of 5s. So that goes outside of our factor, or outside of our root. And then anything that is not with a partner just gets multiplied and stays underneath. So you get the same thing both ways. If you like the factor tree method and you use that, that's fine. That will work. It just depends which one you like more, which makes more sense. Okay, let's do a few to review. Like I said, we have done this. You should know this. Okay, what do you notice about number 1? What can we do with 25? Okay, so we are going to do -2 times 5 because it is always multiplication, which is -10. That is our answer. So we end up getting rid of that square root because it was a perfect square. Okay, number 2, when I have variables underneath, anything that is squared will simplify. So the square root of x squared is going to just be x if you take the square root of a square. So if I separate this into factors, I would call this square root of 49 times square root of x squared. I can simplify both of these. So this becomes square root of 49 is 7 times the square root of x squared. That is just basically an inverse operation. So we get 7x. Number 3, how can I rewrite 45?
5 times 9.
Good. 9's a perfect square. So I'll do square root of 9 times square root of 5. When you have variables that go to exponents, remember your exponent rules. So x to the third could be rewritten as x squared times x, right? Because if we are multiplying, we would add the exponents. So to get to x to the third, we could do x squared times x, and then times y squared. And then I'm going to circle the ones that I can simplify, because these are all perfect square factors. Okay? So square root of 9 is 3. Square root of x squared is x. And square root of y squared is y. And then the only two that are going to be left under my radical are 5 and x. Those are multiplication. Remember, we can go from the separate to the together. So under our radical is going to be 5 times x. So that is my simplest form. Okay? All right, number 4. Okay, 2xy squared. This is nothing we're going to do out here because that's outside our radical. But we're going to rewrite this as perfect square factors. What should 8 become?
42.
Square root 4 times square root 2. What should x to the 7th become?
6.
Okay. I'm going to split it. I like to see every step so that you don't miss one. To get to 7, we have to do 2 plus 2 plus 2 plus 1. X to the 1. It would be to the 6th. But do you know how to simplify to the 6th? What should it be? When you square root x to the 6th. That's why I want to do it this way. Okay, times y squared times y, because it was y to the 3rd. Circle all the ones you can simplify. 1, x squared, x squared, x squared, y squared. So we're going to simplify all of those. Don't forget your coefficient out front. That's going to be part of it. Then, with what we could simplify from our roots. Square root of 4 is 2. And then we're going to have x times x times x, which is going to be what? X to the 3rd. And then square root of y squared is y. Underneath our radical sign that's going to stay underneath because it can't factor out is the square root of 2x y. And then our last step is we're going to do the multiplication here to get our coefficient fully simplified. 2 times 2 is 4. X to the 1st times x to the 3rd will give us x to the 4th. And y squared times y to the 1st will give us y to the 3rd. And then our root 2xy. So that is our simplest form. So this is a little bit more complicated than what we did initially because now you have some variables and exponents and stuff like that versus just numbers. Okay. Number 5. What would you do with number 5 using what we know about division of square roots? Okay. Square root 25 over square root 36. If we try to do 25 divided by 36, that's not going to be easy for us. But if we separate them, these are both perfect squares. So square root of 25 is 5. Square root of 36 is 6. Done. Okay? And we can go the opposite way. So we could try to do the square root of 80 and simplify that and put it on your desk, Charlie. Or we could put them under 1 and say the square root of 80 over 5. What is 80 divided by 5? Well, if you did it, you would get the square root of 16, which is going to be easier because square root of 16 is 4. So you kind of want to see which way is going to be best to help you solve more simply. Okay, let's look at number 7, because this one has division and a lot of multiplication. Okay, what I would want to do is I would want to put the division sign over both. So I would want to go like this. No, not like this. Actually, let's do it like this. Let's separate 14. Does it have any perfect square factors? No. So we're going to square root of 14, x squared, x. And then on the bottom, 2 times square root of 4 times square root of x squared. Do you see how we separated all of those? Okay. Circle the ones you can simplify, which is a lot. Okay, not square root of 14. That was wrong. We cannot simplify square root of 14. I meant to just do the x squareds. So this is not, we're not simplifying this. All right, so let's simplify our x squareds and then our denominator. Okay, so we get square root of 14 and then times, this is x and this is x, so x squared. And then that square root of x doesn't simplify. And on the bottom we get 2 times x, right? So on the top, we're going to have 14x underneath our radical and an x squared on the outside over 4x. There's one more thing we can simplify. We cannot touch what's underneath the radical. So like you can't simplify under there unless you're pulling out perfect square factors, but we have x squared divided by x. What should I do? How do I simplify x squared divided by x? Remember that when we have exponents and their bases are the same, we subtract. So x squared minus x is going to give us x to the first. And this is our simplest form answer. We cannot have a negative number with an even index, a radical with an even index. So a square root, a fourth root, etc. You cannot leave a negative number under the radical. The key is that I is equal to the square root of -1. So that is the definition of an imaginary number. We can solve for imaginary roots, we just can't graph them. So if I was going to simplify the square root of -27, we rewrite it as factors. Square root of -1 times perfect square factor 9 times root 3. And then circle what we can simplify. Square root of 9 is 3. Square root of -1 is I. And we could not simplify the square root of 3. This is where your calculator will help you. It won't tell you the perfect square factors. You have to know you want to divide by 4, 9, 16, 25 to see what goes in. What ends up going in is 49. So this becomes 3 times square root of -1 times square root of 49. Exactly, that's why we want to use it. Times 5. And then split up our x's. Times x squared times x. Do you see how we split that -245 into factors that then we can simplify? Circle what we can simplify. -1, 49, and x squared. Those are all simplifiable. So we get, 3 times I times 7 times x. Well, that has to stay underneath. So then underneath our radical, we have 5x because those ones did not simplify. And then out in front, we do all this math. 3 times 7 is 21. Oops, 21. And then x, and then the I always goes at the end.
Does that need to be at x squared?
Nope, because we just simplified x squared one time, which was just 1x. So this is our most simple answer. Okay. Multiplying one radical by another, or a radical by a whole number without a radical. You multiply, the coefficients, which are the numbers in front of the radical. They are not the index. This is a coefficient. 3 is a coefficient. Okay? If you have a 4 in here, oh, it's not letting me write it. That would be the index. If this was a 4, that's an index. This is the coefficient. Okay? So we multiply the coefficients, and then we multiply the radicands, which are the numbers underneath the square root sign. And then you must always simplify. So then we go to that step that we were just doing and make sure that there's nothing underneath the root that can be simplified. For example, number 8 says, what is the product? What does product mean we should do? Multiply. Okay, so if you are asked to find the product, you're multiplying the two terms. So we're going to multiply the coefficients. 6 times 3. This goes on the outside because it's a coefficient. And then we multiply the radicands. Square root 18. And then we ask ourselves, can we simplify our radicand? Does 18 have any perfect square factors? Good. So this becomes coefficient of 18 times square root of 9 times square root of 2. And then we simplify.
3.
Square root of 9 is 3. 18 times 3 is 54. And then square root of 2 could not simplify. So this is our answer. Okay? If you have like a whole number times a radicand, you just multiply the whole number times the coefficient. So we get 18 root 28. And then we have to check what? If it has any perfect square factors. Do any perfect square factors go into 28? 4 and 7. 18, square root 4, square root 7. And then we can simplify this to 2. So 18 times 2 is, 36 root 7. Oop, not root 2, root 7. Okay. If there is nothing in front, like number 10, what is technically in front of square root 5? 1. So we get 2 times 1, which is 2. And then we multiply our radicands. 20 times 5 is 100. 100 is a perfect square itself. What's the square root of 100?
The answer's just 20.
Yep. So we do 2 times 10. We got rid of our root because it was perfect, so we get 2 times 10, which is 20. So remember, it's always multiplication when we have a coefficient next to a root. Okay, in this case, what am I going to have to do with the 2 root 5? You're going to have to distribute it. You have to distribute to both of these, so we have to do that multiplication twice. So first, we'll do 2 root 5 times negative 5 root 10. 2 times negative 5 is negative 10. And then the radicands, root 5 times root 10 is root 50. And then we have to do 2 root 5 times root 6. So this becomes plus 2 root 30. Now, can we simplify either of these? Which one? 50. 50 times... Rewrite 50 as root 25 times root 2. Does 30 simplify? No. So this is going to stay. So we can simplify our root 25, which is 5. So we end up with negative 10 times 5, which is negative 50, root 2, plus 2 root 30. And we cannot add those. We have to keep them separate. We'll talk about adding next time. Okay? So you cannot add unless they have the same radicand. Try number 12 on your own, please. Try number 12 on your own. The basics. Coefficients times coefficients. What's the coefficient of 20x squared, root 20x squared? Technically, there's a 1 out here. So 1 times 3 is 3. Then we put our root, and we multiply our radicands. 20 times 5 is 100. X squared times x is x to the third. And then we need to simplify the radical. Square root of 100, because that's perfect, times square root of x squared, times square root of x. And then, what can we simplify?
That's 10.
Both of those. 3 times 10 is 30. Square root of x squared is x. And then that square root of x doesn't simplify. So our answer, 30x, root x. Try to divide by putting it all under one radical.
I'd say probably the second one.
I'm going to try this.
That's what I was gonna say.
What is this binomial? What do we call this pattern when we have a perfect square subtracting another perfect square? This is back to factoring 101.
You gotta subtract x, but
It's a difference of squares. How does this factor? X plus 3 times x minus 3. Do you remember this? When we have a difference of squares, there's a special pattern that it factors to. Square root of the first plus the square root of the second. So square root of x squared is x plus the square root of the second term, which is square root of 9 is 3. So this is a pattern that we have to recognize. It's going to keep showing up. Over x plus 3. What can I eliminate? Right, so I have this. I can cancel those because they're a common factor, which just leaves me with square root of x minus 3. There's nothing more that I can simplify here because nothing's a perfect square, plus it's 2 terms, so we are done here.